Hello, everyone, and welcome back to this episode of Tooling Time, episode 3. I am Tony Harper, and I'm joined by the amazing John Vincent. How are you doing today, John? John is our master application engineer when it comes to all things CAM, and we like to host these little episodes of Tooling Time to just give a brief insight into the world of CAM and run through some of the processes that many engineers might face on a daily basis today. This episode is kind of the thrilling finale to the past 2 episodes of Tooling Time that John hosted. But before we get into this episode, John, if you want to do just a brief background on what you covered in the last 2 episodes, that'd be great. Perfect. And like always, if you have any comments or questions, feel free to use the chat in either the YouTube chat or the Twitch chat. I'll be monitoring both. And at this point, I'm just going to pass it on over to John for the first part of the show. If you want to go ahead and share your screen.
going to be the center of my part. However, I'm going to also offset this. I'll just use a rectangular offset. And I want to be 3 inches up above the top of my finished face, which currently the point I selected is already 1/4 inch up. So I'm just going to do an offset of 2 3/4 inch for this initial point. And I'll accept that initial position. You can see as I'm going through building these motions, you can kind of see that my probe is in position. And so this is definitely a little bit different than your typical CAM operations where you're just purely selecting a cut method and specifying some geometry and things like that. We're kind of specifying and moving point to point here in these operations. And I'm going to go ahead and just to kind
of how this works out, I'll make another motion here. I'm going to use the linear move along 2 axis and location. We're kind of working in a sequential order here. So currently I'm 3 inches.
Does the audio sound right to you?
So I'm going to move -2 inches in Z.
case, I'm going to toggle on protect it move. I want to output a Renishaw cycle. This would be a P9810 in this example, and a protect it move means if the probe is triggered, if it touches any surface, it's going to stop. It's not looking for any measurements or anything like that. Using full simulation, and we can see that, yep, now we originally were kind of up higher on the part, and now we're stepping down, getting closer to our location to that we want to probe. And then here, my next step is I want to actually probe this top surface. So again, create another sub operation, and we'll come down and use the probe point sub-op. And we can see this dialog looks very similar to the probe parameters page that we looked at. And this is where I'm going to make some additional settings in here. But initially, I'm going to go through and just specify the point that I want to probe. And like I did before, I'm just going to use this between 2 points option. And that's selecting the top of the part that I want to probe right now. And you can see it's inheriting kind of based on my probe or the point that I selected, what direction do I want to probe in? And I am going to be probing in the ZM minus direction. You could certainly change this to probe other surfaces as well. And I have 1/4 inch of stock on this part right now. So I'm going to enter that into my part stock field. And I'm not going to change any of these different approach types. I don't need to do anything special here. But what I do want to do in this probe operation is I want to have the results written to my G54 offset. And so to do that, the Z0 offset field, I'm going to enter in a value of 1. And as you know from your mill MCS, your fixture offset 1 is corresponding to G54 in the case of FANUC controls, which we have on this FANUC-based control on this machine. So by putting in a value and toggling on this checkbox, that's going to output an S word in our probe cycle, telling the control to write the results to the control. We'll see the results here in a little bit. I'll press OK. And the last thing I'm going to do is I'm going to use a user-defined event to offset the results 1/4 inch in the minus direction. So here I'll go to machine control, and I'll use this insert command. And I'm just going to use some of the results from the probe. Currently, the top surface would be written as Z0. And I'll use some of the machine variables in this case to offset these values. And in this case, I'm just going to offset #5221 is where Z0 for G54 is written. And I'm just going to do a little math. Minus, let's see, I want to subtract a 1/4 inch from this value. And maybe I'll even add a little note here. Shift Z0. And I'll say OK. So we can see we have our clearance plane. We're moving down to 3 inches above our part. Then in a protected move, we're getting down to 1 inch within our part. Then we're actually going to be probing that surface. And in this case, I think I want, there we go, 0. Because I already selected the point as with that 1/4 inch of stock. And then I'll put my machine control, that insert command to really shift our coordinates. Let me go ahead and say OK. And I'm just going to reorder my operations here. This is going to be the very first thing we're doing in this program. You can see a couple of my operations went out of date, and that's fine. We'll fix that up here in a little bit. So just to show what the results look like from a probe operation as far as the code is concerned, I'm going to go ahead and post this code out. Now I've modified my post to handle some of the probing operations. And we just want to look and see what some of the results are. So here we're doing a couple unprotected moves. That's what cycle 9809 is. And we're moving X and Y to 0. That's the center of my block. And we're moving Z to that 3-inch height above our finished face. And then we're going to go in a protected move, P9810, to 1 inch above the finished face. And then we're going to probe using the cycle 9811 at that Z of a 1/4 inch above our finished face, what it's currently set to. We're saying that we've set this originally, and now we're going to keep loading parts. So we're always going to be in the ballpark, but we're going to probe every part, set that Z. We're dropping it a 1/4 inch here, so we're overwriting in our control. So we're going to be set to that Z0 height. We're always removing a 1/4 inch of material of stock from our blank material and establishing that Z0 height. So this is kind of how the format is going to follow and be output from our post. All right, so we've set our, actually one other thing I do want to show here before we move on. By checking the 0 offset, we're outputting this S word, S1. This is telling the cycle to write to our variable for G54 for our Z offset. If I had not checked that box, this S would not have, this S value would not have been populated here, and it would purely be measuring that value. So that's just one of the ways that you can utilize probing for writing to work offsets. All that logic's kind of built into the Renishaw cycles. All right, so we've established our Z0 height. Now I want to probe the block in X, so it's going to be probing on either side of the block, finding the center location, and the same actions are going to happen in Y. So now this is not supported out of the box currently. Like I said, I think in 1980 it's going to be supported. I know Siemens is working on this. So I've created, here I've gone to my template that I've made, and I have a number of different generic motion probing types that I've created. And in this case, I'm going to use my 9812 probing the X web. So let's go through, let's see. Yep, I have my probe selected, op1, mill finish operation. And yep, this is going to be using the 09812's template, probing our G50 or setting our G54 X location. So in these custom templates that I've created, what we're doing is setting some variables here. These are some inputs that as a programmer I'm inputting, and we have a number of linear moves, different moves that's going to handle the actual motion of the tool. But from the programming standpoint, all I'm going to do right now is I'm specifying the center of my block. I need to change my selection intent to entire assembly right now. And I will specify the center of my block. So let me come down here and I'll just pick that point and offset in the Y direction 1.5 inches. We're working on a block that's 4 inches by 3 inches. And so looking at the values here, my length in X, that's kind of going left to right as we're looking at the screen right now, is going to be 4 inches. And I'm going to probe at a depth of 1/4 of an inch. So I don't need to go through and change any of these sub operations. Everything's built in there into the operation for me already. Oh, let me zoom back out a little bit here. Let me just go ahead and generate. And when I do that, you can see, I'll go ahead and do a verification. You can see all the motions are created for me to go ahead and probe this block in the X positive and minus directions. And I'll go ahead and say, okay, that's all we really need for our setting our X. I'm going to go ahead and insert another operation here. And this time I'm going to use my Y web operation that I've created. Program, yep, everything looks good there. Say okay. And I'm going to pick that center of the block again. I'll do this exact same steps here, just offset my point I picked. And let's see here. In this case, the block is 3 inches in width. So I'll go ahead and generate the code or generate the tool path, and you can see the motions that are going to be made by this tool. And I just want to take a look at the code real quick. So I'm going to post out one of these operations. And in this case, we can see we're doing some non-protected moves, just positioning the tool. Then we're coming in with a protected move, this 9810, and positioning 3/4 of an inch up above the part. And then we're calling 9812. This routine will program probe the web of our part or opposite sides. And we're simply saying X is 4. That's the width of the block. And we're going to program at a negative 1/4 inch Z height. So that's going to program or probe essentially 1/2 inch below the top of our part. Remember that our raw stock is set to a 1/4 inch above our Z0. And we still have our S1 being output. That's going to write this X value, the center location of our block, to our G54 work offset page. And Y is going to behave the same way. And since some of these operations went out of date, I'm going to go ahead and just approve them. We don't need to spend the time generating those tool paths again. And so we now have our operation to set our G54Z. We're setting our G54X and our G54Y locations. All right, so that's great. I think we are ready to start probing, doing some of our inspection probing. But before we do that, I'm going to throw it back to Tony, and we're going to show a little bit about an event, NX University, that we have coming up here shortly.
Okay, everyone, and back to tooling time. Before we get back to the session with John, I just wanted to touch on NX University, which you just saw a little preview of. On March 17th, we are hosting our spring session. It's a virtual session of NXU, our second one, where our application engineers will cover a bunch of really cool topics, both CAD and CAM. And we actually just released the agenda this year, a couple days ago. You can go ahead and register for that over at NXU University, where you're also able to see the agenda. John, if you wouldn't mind, would you briefly touch some of the topics that you will cover on the CAM side of the event?
Yeah, certainly. From the CAM side, of course, we're going to go through what's new in the latest versions. So this will be covering a lot of the content in NX 1953. So there's some new features specific to that version, but we'll also cover other topics that have been new or relatively new in some of the most recent releases. Seeing as how we have major releases every 6 months, we're continually getting a lot of new information. In addition to that, we're going to cover some main topics looking at how we can really utilize our IPWs in our setups, and maybe some differences between some of the new features, and we're going to focus some sessions on the difference between post builder and post configurator on how you can create post processors for your machine tools.
Perfect.
So that'll be just a little preview of some of the stuff that we'll be covering in this spring's NX University.
Yeah, awesome, John. Thanks for that. I know we're all really stoked here for the event. And with that, I'm going to let you take it away with part 2, finishing up.
All right, excellent. So we're ready. We have our first 3 probing operations done, and now we're going to go through and jump back into doing some inspection. So again, this is kind of the 2 major aspects, at least how I think of probing on a machine tool. One, we're using it for setup, measuring or setting offsets, and the other would be to do some in-process probing of checking features, maybe using the information to adjust cutter compensation values or something like that. So this is going to be on the inspection portion. Same operation types here. I'm going to start with mill part probing, and I'm still going to be working in my op1, all the same work pieces. And in this case, I'm going to measure the bore. So that's what I'm going to call my operation. Measure D 1.625. I think it's a 1 5/8 inch bore. And so again, using all the out of the box information, I always go through, start with my probing parameters, set my output type to ball contact, and start adding some new sub operations. So this is going to follow suit very similar to what we did with our probing of the Z surface, where I like to come in and first specify a clearance plane. Again, just offset from our finished face. I'll come up 3 inches again, kind of just personal preference there. There's certainly no requirement to use that value. And we're just going to need 2 additional sub operations here. The first is going to be a linear move to point. That's going to bring the tool near my part. And I'm just picking this center part of my center point of my bore, and I'm going to go ahead and do a little offset here. Rectangular offset, move up in the Z direction. And before I close this menu, I am going to specify that this is a protected move, and then I'll press set OK. And now we can go in and actually use the probe cylinder option. So from the pull down menu, I'll choose probe cylinder. And in this menu, we can actually select some geometry. So we haven't kind of done this. We've always been working with points so far. But in this case, I'm going to choose the bore that I'm going to be measuring. And you can see that NX defaulted looking at the geometry and established that, yeah, I'm measuring an internal feature right now. You could also measure an external feature, and we'll do that next. And now for setting the Z height or the Z location of where I'm going to be probing, I'm going to accept the default option here of midpoint. It's just going to find look at the feature itself and find the height that's right in the middle, and that's where it's going to probe. I could also choose to specify and set a height if I wanted some specific region to be probed. but the midpoint is a good option for me. So in the previous operation, we set our Z0 or our Z offset because we wanted to write to our work offset page. We no longer want to do that. We just want to get the values back. So I'm just going to press OK. I don't need to change any other settings in this operation. And you can see how these out-of-the-box operations work, that they're still kind of positioning our probe. But here's what's kind of a downside to the current workings of our probing operations. We don't see the actual motions, probing 4 points or 3 points or whatever your selections are inside of the verification. You'll only see that if you do true simulation and have the probing cycles added, which we're going to do here in a little bit. But just showing a little bit of the difference between some of the out-of-the-box support and the way that you can customize things right now. Okay, so I have my feature probed. I'm just going to copy this operation, and I'll paste it. And I'm going to create another feature here. I'm going to measure the boss. And what is this? I think it's 2.375, and this is going to be a boss. And I just noticed I don't know how to spell measure, so let me go ahead and fix that. Not that it's important. But I'm going to go ahead and just edit this existing operation now. So this is a quick way to just go through and kind of modify an existing program. So here I'm going to deselect this boss or bore feature, and now I'm going to select the boss feature. See, NX automatically recognized that this is an external feature, so it changed that location. But I'm still going to use the midpoint. I have enough clearance on this probe to do that. And so I'll say OK. And now I'll make sure both of these operations are generated. And again, like we stated before, the verification is a little bit deceptive in here. So the posted code is all going to come out correct, that it's going to probe this diameter of the feature, and it's going to probe the internal diameter of this bore. But the verification is a little bit lacking here. And this is one of the next big enhancements for probing, on-machine probing. But I think we're good here. As far as our first operation, we've measured our features. We're ready to start looking at the second operation now. And so again, to reuse some of these operations we have, I'm going to go ahead and copy this bore that we've already measured. And I'm going to paste this down into my operation 2. And I'll just reorganize some operations here. I'm going to say set, or call this set XY G55. We're using G55 offset on the second operation. And I'll go ahead and edit this op now and change a few things. First, my geometry group. I need to use my geometry group for operation number 2. So I'm making that change. And I need to update the values here and different parameters. So my clearance plane, I want that to be based off of the Z0 finish location of my operation 2. So let's offset that 3 inches again, value I like to use. Linear move to point. Of course, we're not working on this first part anymore. We're working on the second part. So I'm just going to go ahead and reselect a new point. And again, I'll do the rectangular offset, just moving my Z0 up 1 inch from the finish face. And probe cylinder. We're going to be probing the IPW, the existing IPW, the kind of raw stock. So we don't have a feature to select right now. So instead of using the cylinder method, I'm going to choose to use the point method. And I'm going to come and just select the 0 point of this this face, kind of the center of this arc. Now, if you can imagine, I know that I have a 1/4 inch of material up above this point. So I don't need to do any probe setting distance. If I'm at probing at this Z0 location, that's going to be perfectly fine for my tool. I do need to specify the diameter of the feature that I'll be measuring, and this is just a 1/2-inch drilled hole. So I'm going to enter in 0.5 for my value. And again, come down to probe control because we do want to set our work offset this time. And it's going to be offset G55, which is our fixture offset number 2 inside of NX. All right, so we've updated our point where we're going to be probing, and that will write our offset to G55 now. We can just do a quick post this operation real quick, just verify that everything is looking good. And let's come down. Yep, we are calling offset G55. And when we do our probing, we're going to be using our 9814. We've already had a protected move position us at Z0. So we'll be down inside the part at that point in time. And we are writing to offset number 2, which is G55. So that's all looking good. Same thing. I'm just going to go ahead and approve these operations for right now. Of course, you would want to most likely generate them. But just for the sake of time, I'll use the approve method. And I'm going to measure one last feature here. I'm just going to inspect this, this 2-inch bore. So again, I'm going to, in this case, I'll copy the probing operation I did to set my X and Y location. And I'm going to paste this to be the last operation of my program. And we'll say measure D 2.0. And this is a bore. And I'll quickly go through and just modify this operation. In this case, all I'm going to be changing is my probe cylinder. We're going to switch back to the cylinder method, and I'll select the actual part geometry. And we'll switch back to measuring at the midpoint. And I no longer need to specify a 0 offset. I just want to measure at this point in time. And we'll generate that operation. And I think everything is looking good there. For my machine kit, I've just kind of been building this machine for this use of this class here, or this demonstration. I have a little bit more work to do on the simulation. I know I have to put a little flag in here to identify my when I'm probing a boss right now. So I'm just going to use a user-defined event, just to set a variable. I need to, when I get a little bit of time, I'll make this automated here. So I'm just going to set a value to equal to 1. I just use this as a flag for the simulation itself. Doesn't affect anything on the machine code. All right, so we have probing added to both of our operations now, both setting offsets and measuring some features. And so let's go ahead and look at running this simulation. So right now the post is going through post-processing the code. You can see my IPWs have been generated. And I'll just kind of clean up my screen so we can see this a little bit better. This is just a warning screen that comes up when the post is done running. And we're going to start just by watching the simulation here. So I'll go ahead and play this. And the first thing that's going to happen is my probe has been loaded into the spindle. And we're coming down and we're going to touch that first surface. It's gone through. It's set the Z offset. I did the math. I wanted to shift that 1/4 of an inch. So I have that code output that I used as a user-defined event. And now we're going to come back and use our probing routine 9812 to probe in the X direction. And I'll speed this up, slow it back down. Now we're going to do the same thing in our Y direction. Oh, and I must have had the wrong value. Yep, I didn't. So that's good that we caught this. Let's stop. And I never changed my Y width here. Let's change that to 3. And as soon as I change that value, yep, I should have looked closer when I was making my tool paths. Regenerate that. Now it's going to program the proper width of that part. And we'll jump back in and do that machine simulation again. I had my collisions turned off. Well, maybe I didn't. So I would have been able to catch that. But let's go ahead and post out that code, just get that warning message out of the way. And now we'll play this. Let's get caught up to where we were. There's X. All right, now we can see it probing Y. So this is a great example of why simulation is important. That could have gotten out to the shop floor. Wouldn't have broken anything, but the probe would have alarmed out when it touched the top of the surface before in a protect it move. But great example of why simulation is so important. All right, I'm going to speed this up and let the simulation run. We've seen this last week, how we're actually milling this part. So I'll let that go ahead and work its way through. And we'll stop it before we get to doing the next probing routines. All right, and here we come. We're going to do one last little chamfer there. And now we're going to come in and do some more probing. So first it's going to come in and probe this bore. And for the sake of this class, I just did the standard 4-point bore. I could have done a 3-point bore. That's probably what I would have done in this case, and specified some different angles. But for the sake of this demonstration, and just to move things along a little bit faster, I just did a 4-point bore. Obviously, this wouldn't really run on the machine. We would get an error when it was trying to probe that little groove location. But these are all things that you can build in. You can have checks to see, did it actually touch a surface in the program? You could certainly set that up in your simulation. All right, so that wraps up the operation 1. All of these measured values are getting written to some machine variables right now. And that's kind of another topic. What do you want to do with those values? As you can see here, we're measuring our 1/2-inch diameter hole, and that's setting our XY location. And now we'll go through, same thing, run through the rest of the machining operations. And do some drilling and tapping here. Before we get to our final probing operation, where we're just going to check that bore. So that brings up the topic is, one, you can take these results and just look at them and say, yep, I'm in tolerance, I'm out of tolerance, I need to make some tweaks. Depending on what you really want to do, there's very little limit in how you can modify the use of the results of your probe routines. You can update cutter compensation values. So you're continually tweaking the cutter comp values to always stay in your target values for your part. You can do other things like have the machine alarm out if you're outside of tolerance. If you blow size on this bore and you're over the tolerance, you can have the machine alarm out so the operator is automatically or right away notified that something with this part's not in spec, and they can then look and see, can we rework it? Can we salvage this part, or is it going to be scrap? So this is where you need to start using some of your creativity and really understanding what do you want to accomplish on your machine in your shop, and we can work with you to get that done inside of NX. All right. So that's really the extent of this overview of probing inside of NX. So I hope everybody found it beneficial. And if you have any feedback, if you'd like to learn more about, more of what can you do with the results, or how to go through and create some of these custom operations using generic motion, I would certainly love to hear some feedback, and we can help make some more videos going forward based on that content.
Yeah, awesome. Thanks, John. And I just wanted to take a quick little second to mention that we are taking a little hiatus from Tooling Time for the next couple weeks so that John and everybody else has time to prepare for NX University, which again is swiftly approaching. Don't forget to check out the agenda if you haven't seen it yet and register at nxuniversity.com. And that being said, we'd love to hear from you guys further about Tooling Time, about what topics you'd like to see or what challenges you're facing in the CAM world, so that we can really orient these towards you guys. Again, thank you so much, John, for the awesome episode, and we hope to see you guys at NX University. Thank you so much. Signing off.
All right. Bye, Tony.
Bye.